Hello everyone, let's do one simple exercise today. This is comparing the enthalpies of cis and trans-2-butene. Let's open Argus Lab and new file. I'm drawing structure of butane first. Alright, 2, 3 and 4. Okay, add hydrogens. Go to selection tool and this is the structure of butane. Before I convert this to butene, I would like to clean this geometry, butane, and save. So here is the structure of butane. Now I will convert this to butene. For that I am supposed to convert these two. Let's label first all atoms. C2 and C3, I will change them to sp2 hybridized carbon atoms and delete one hydrogen from both the carbon atoms. Click on this hydrogen, press delete button from your keyboard, select one more hydrogen, delete. Convert this select this carbon atom, select this carbon, right click, change atom to sp2, trigonal non-aromatic, select this carbon, this bond is selected. Okay, let's convert this to double bond and this carbon again, this carbon atom to C2, change atom sp2 non-aromatic. So here is the structure of trans-2-butene. Again, let's clean the geometry. Go to this icon, clean, and optimization is converged. So this is trans-2-butene. Now we are supposed to calculate its heat of formation and optimize the geometry using quantum mechanical methods. So these are three semi-empirical quantum mechanical methods: AM1, PM3, MNDO. Let's select AM1. You can select any of these and then start. So geometry optimization converged. Let's see an output file. This is output file and control F. Where is the heat? HEAT, heat of formation. Fine. So here it is. Heat of formation for this butene is minus 1.1859 kilocalories per mole. Control C. I can paste this value in my file here. This was trans. Control here it is. Control V. Control S. Okay. Okay. You can close this file, otherwise it may create some issue. Okay. So here it is. Now how to convert this geometry to cis-2-butene? We are supposed to change the dihedral angle. Okay, before that, let's capture this image also. Save this image in JPG format. Export. Go to file and export. Then I select the folder. Here, JPG format and save. Right. Now I will convert this to cis-2-butene. For that, I am supposed to change the dihedral or torsion angle. Carbon 1, control press, carbon 2, 3 and 4, 4 and bond should not be selected. And then go to monitor torsion. Okay, so this is minus 179.98. It is 180 degree almost. So these are in opposite direction. I will click on this green line and set its value to 0 degrees. 0 and then OK. So see, the angle has been changed and it has become cis-2-butene. And now we are not it's not necessary to optimize this geometry again. We will simply go to calculations and do single point energy calculation using the same quantum mechanical method which was used to optimize this geometry, AM1, and then start. So it is showing self-consistent field converged, and the energy calculated is this, but we have to note down the heat of formation. Go to output file, Control F, heat, and here is the heat of formation of this. Okay, I will select this value, Control C, and paste it in my Word file, Control V. So here are the two values for cis and trans-2-butene. This way you can calculate, you can paste the images of the two here, you can capture it. Again, go to file, export, and JPG butene, and let's name it, this is cis. Save. Calculate heat of formation for any of the molecules. Thank you.